In order to solve letter A, we must use a position formula. And the formula that I found was the final position is equal to 1/2 times acceleration times time squared plus the initial velocity times time plus the initial position. I just then substitute for the values I knew. I knew that the acceleration was minus 9.8, the initial velocity was 100, and the initial position was 300. And then I just solved. I multiplied 1/2 times minus 9.8 times t squared, and I got as a result minus 4.9 t squared. And in this ones I just multiplied the value for the t, and I got 100t right here. And since this one wasn't doing anything, I just pass it as it was. First of all, in order to solve letter B, I had to investigate where a derivative to the limit was, and I found this equation. I just then substitute the values I had from the previous exercise, and I substitute them, and I got this thing, minus 4.9 times t plus h squared plus 100t plus h plus 300 minus the function that we had in the previous problem, which is this one, all divided by h. Then I started solving this times this and everything, and I got this big result. And what I did after that was that I canceled the terms that were the same but with different signs, and what I'm left with is minus 9.8th minus 4.9h squared plus 100h all divided by h. And in order to get rid of this h, I had to factorize the h out, and what I'm left with is h times minus 9.8t minus 4.9h plus 100 all divided by h. I cancel these two terms, and what I'm left with is minus 9.8t minus 4.9h, which is equal to 0 because h is 0, and then I cancel it plus 100, and my final result is minus 9.8t plus 100.
Since we know what is the value of velocity, we can solve the value of the acceleration. So we take the formula that Andre gave us, that it is minus 9.8t plus 100, and we apply this formula that it is n is equal to minus 9.8, and x that it has to be a variable that it is t, and we have to subtract minus 1 in this formula. So we know when a variable doesn't have exponent, it is equal to 1, so 1 minus 1 is equal to 0, and when it's 0, you have to put 1, and minus 9.1 times 1, it is equal to minus 9.8, and when a constant doesn't have exponent, it's equal to 0, so we eliminate this, and the result is minus 9.8 meters per second squared.
The height of the bottle after 2 seconds, we obtain it with the position formula equation, and we substitute t for 2 seconds, and we apply the 2 seconds in all the equation, and we obtain it minus 19.6 plus 200 plus 300, and the final result is 480.4 meters. To obtain the total time of the trajectory of the bottle, we use again the position equation. Y time, we substitute equals 0, and when to obtain time we use the general formula. The values are the next. A is equal to minus 4.9, B is equal to 100, and C is equal to 300, and we substitute the values in the general formula. We obtain the result of minus 100 plus minus 126.02 divided by minus 9.8. and the time 1 is equal to minus 100 plus 126.02 or divided by minus 9.8 is equal to 26.02 divided by minus 9.8, and is equals to minus 2.7 seconds. And this answer, this result is cancelled because the time can't be negative. Always the time is positive. And the time 2 is minus 100 minus 126.02 divided by minus 9.8 is equals to minus 226.02 divided by minus 9.8, and the result and the total time of the trajectory of the bottle is 23.06 seconds.